Thank you so much, and really appreciate you all coming in for the session. I hope that you find this information useful. Just wanted to discuss a bit about the architecture that we have for AlloyDB for Postgres. And with the new advances in generative AI, HTAP, just wanted to touch on a few of the aspects about AlloyDB, which I thought might be of interest to this crowd here. So before actually I jump into the presentation, just wanted to quickly introduce myself, give you some background. So I've been at Google Cloud for about 5 years. I'm in the database product management team. And before that, I spent like 20 plus years at Oracle. So I was in the Oracle database team there. So I have seen the evolution of the database space, all the way from client server internet, like they used to say with Oracle 9i, all the way into all these cloud native databases. So it's been a really interesting journey, something that has really helped me get into the system side of the databases, the feature functionality around SQL, the fact that now databases can work across a multimodal environment. So as you all are seeing, databases are still at the center of all the activity that goes around all these technologies that keep coming up. So it's really important that the database stack keeps evolving. And that's where I wanted to highlight what we have done at Google. So if you look at Google, right, we have a lot of large workloads that we run in our environment. And many of these applications have billions of users. So think about all the backend data that is getting managed for these. So you think about YouTube, you talk about Google Ads, Google Pay. All of the information that is being managed for this runs on the Google infrastructure. So what I wanted to do next is briefly talk to you about the Google infrastructure, because it's interesting for all of us to understand, right, how we come up with this massive scalability. How do we come up with this functionality that can work with both NoSQL and SQL workloads, and now more with generative AI and HTAP. And that basis is what we are building AlloyDB on top of. So if you look at the very bottom of the slide, we have Colossus, which is our storage tier. And Colossus is this 11 nines availability, highly reliable storage, high performance. And everybody has heard about the Google networking, so that's a big differentiator. We get a lot of speed from replication with the Google network. We then have a disaggregated compute. So when you talk about databases, there's obviously a model where you could have the database CPUs take care of all of the action when it comes to the underlying storage and memory. Or you could have helper compute, disaggregated compute that can quickly come in and help you around things like replication, for example, or help you in terms of setting up read pools so that read workloads can be segregated and does not affect your OLTP performance. So there is a lot of advantages that you can get from a configuration that has a globally distributed storage and then disaggregated compute. And beyond that, we have the foundational models. If you look at LLMs, right, we support a variety of foundational models, and those are available for you to use as you build out your AI application. The other key area that I want to highlight is this data processing tier. And when it comes to data processing, what we did is, again, Google has been doing analytics for a while for all of our use cases that I mentioned earlier. So we have a columnar engine, and that columnar engine is something that we have incorporated into AlloyDB. And AlloyDB for Postgres is what I'm going to cover in detail. We also support the PG vector interface, so vector processing and the fact that we are able to do it in a standard fashion is something that you can take advantage of. Google has spent 12 plus years building out some of these new indices, like scan indices, for example, for vector searches. And I'll show you some stats on that. All of that information is incorporated into the database platform. And then we talked briefly about the Google network. So the whole idea is, how do you combine all of this capability into something that is, open standards compliant. So if we look at how developers are, essentially going and using databases, both MySQL and Postgres, right, are at the top. And what we chose at Google is, to build up a database on the infrastructure that I just described and comply with the Postgres standard. So the reason why we are doing this is, at Google Cloud, we are seeing a lot of large enterprise customers coming over, moving their workload over. And one of the things that they've always said to us is the fact that, we want to bring those enterprise workloads, but one, we don't want to get into a vendor lock-in situation. So open source is very important to them. Open standards is very important to them. But the second thing they also say is, when it comes to open source, we would like to have the support. We also want to have enterprise features, right? So we just don't want to bring small workloads. We want to bring large workloads. So we want all of the features that we are getting currently from the legacy databases. So we had to combine both of those. And that's where as we developed AlloyDB, we spent a lot of time building out those capabilities. So when you look at AlloyDB, the way to think about it is, hey, it's open standards, Postgres in this case, and it uses the best of the Google infrastructure. And what we have been able to do with this setup is really make a difference in terms of the scalability and performance of the product. If you look at OLTP workloads, right, compared to standard Postgres, we have 4 times faster transactional performance, like the TPS that we are able to get. And we have, like, I'm happy to share resources at the end of this slide. I know the previous presentation from Rakuten had a lot of good slides in terms of performance, which is, I wish I could add more of that sort of content here, but we have a fully detailed setup on how you can get similar performance, all the way to the flags on both the VM and the database tier. The second thing I want to highlight is the faster vector queries. And we have, again, made sure we are PG vector compatible, but we have built in a lot of capabilities like the scan index to improve that performance. And then when it comes to the 100x, up to 100x faster analytical queries, Postgres obviously has its capabilities there, but we wanted to even get that going much faster. So we introduced a columnar engine inside, it's in-memory columnar engine inside AlloyDB. So the way it operates is, as customers or developers come in and issue the query, the optimizer is able to detect that it's an analytical query and take advantage of the columnar engine. So it's totally seamless. I have customers and developers who have moved their workload over, immediately start to see these benefits. So that's where we want to make sure that all the large customers, the developers, all of them are able to take advantage of it. And the few logos that I have over there, Character AI, for example, is one. They started with AlloyDB, and with all the buzz around AI, they have suddenly grown in terms of the volume of traffic that they're seeing. So they have a ton of billions of connections. They're growing at a rapid speed, and they wanted a really scalable database. And they wanted a database that could obviously support the write, but they also wanted to support all of the read queries that were coming in. And like I explained, we have read pools with AlloyDB, and we can really horizontally scale. That's what they took advantage of. And another one that I'll highlight here is NeuroPace. So NeuroPace is in the biotech space. It's a startup, and they do analysis of brain scans. So they have a device that helps prevent epileptic attacks, and they are checking brain scans of millions of customers. And they were able to generate embeddings and store those embeddings in AlloyDB and use that as a mechanism for the researchers to look at brain scans like before epilepsy, after epileptic attack, and start to see patterns in there. So really proud of the work we have been able to do there. If we dive down a little bit more into the architecture that we have for AlloyDB, I wanted to highlight the fact that we have Colossus, like I mentioned earlier, which is the distributed file system. But then we have the intelligent database storage engine, which is the disaggregated compute. And what this disaggregated compute can let you do is essentially run like a PostgreSQL kernel in there, and it can take advantage, or it's so close to the storage that it can take advantage of some of the functionality that we can provide there to distribute the load and really scale out in terms of vCPUs and storage. When it comes to the vertical scaling, we can go up to 128 vCPUs. And many times what we notice is performance plateauing off with standard Postgres. But because of this architecture, we have really good scaling all the way to 128 vCPUs. And then in terms of storage, we are supporting 64 terabytes today, and we are going to be able to go to 128 terabytes really soon. So it's all about being able to migrate those large enterprise workloads, right, where customers are paying a huge amount of licenses to run those workloads, and they want to come over to an open standards environment. The other thing that we have done in terms of improving performance is we have optimized many of the functionality, like auto vacuuming is a feature that we have built into the product. We want to be able to make sure that customers are able to manage these larger deployments of AlloyDB. So there's a lot of fully managed functionality built into the product. What I'm highlighting here is how the read pools work, for example. And with read pools, you can scale out to like thousands of vCPUs. The way we are implementing read pools is, if you look at, again, this is more for a Postgres deployment, there is a log sender and receiver, and we have spent time optimizing the log sender receiver. The log sender receiver can take advantage of the storage engine compute, so it's able to offload that. The database vCPUs are not consuming all of that information, or are not busy all that time. And with that sort of optimization, and you can look at the link, it talks in detail on how exactly we've implemented it. But with that kind of setup, we are able to get like a 25x lower replication lag. And now this opens us up to use cases where if it's a catalog or something of that sort, delay in terms of replication is fine. But you are having order management systems, for example, where you don't want to have that large replication lag. Then in that scenario, we are able to take advantage of this feature and open up AlloyDB for a lot more use cases. The other thing I talked about is we are able to give a highly performant columnar engine. So like I said, the data is stored in both row and columnar format in memory. And as the row changes, the in-memory representation keeps in sync. So what you could do is essentially deploy the columnar engine on the primary, or if you want, you can deploy the columnar engine into the read pool only. And the way we envisage this environment is you could have a primary database, and then you could have financial reporting, CRM reporting running on the read pools. And only for the data that is relevant to the CRM application, you would pull that into the columnar engine. So there are a lot of different deployment scenarios that you can look at. And what we are also saying is you don't need to just rely on the primary deployment for your read-only queries. You can very effectively take advantage of read pool, and all of these different applications and reporting systems can be deployed on the read pool, and leaving that primary to take advantage or run the OLTP transactions. So a lot of scalability that can be achieved in this setup. by offloading analytics to the read pool. That's what we are recommending. And the fact that we are lowering the replication lag by 25x really allows you to speed up the availability of this data in the read pools, and it gets to as near real time as possible. The another area that we have been focused on is, obviously we are an HTAP engine, but now remember there's a lot of interest around saving embeddings in the operational database as well, right? Because you want to be able to do near real-time analytics, but in addition to that, you want to be able to do vector search on your operational database. And in the earlier setup, what would happen is there would be a lot of ETL happening because you would take the operational data, push it into an analytical database, you would take the operational data and then generate a vector database. But with AlloyDB, you're able to essentially merge all three of these things into a single instance. And the fact that we have optimized each of these different functionality, we are able to really optimize on speed. We are able to reduce the amount of time it takes to create indices. We're able to reduce the amount of memory it takes to run each of these operations. So you can get more out of your database. So we have price performance numbers as well that showcases how this can be helpful. And the whole idea and the challenge you would have in this environment if you were not able to combine all the functionality into one would be the fact that there's data that is stale, there are data governance issues, there's higher cost. All of that is avoided now that we are able to create a unified data strategy with AlloyDB. The other area that I wanted to also highlight is, we talked about HTAP, we talked about generating embeddings, but what we also see with generative AI applications is the information or the results that come out of these generative AI applications shouldn't have hallucinations, right? You need to be able to ground that information in your operational databases. And that's where, again, we want to build a bridge between the foundational model and the generative AI application. And you all heard about RAG applications. So that's where we, again, wanted to make sure that all of the AI capabilities were built into the database itself. So if you think about Google search and all of the other capabilities, we have been, and there is a white paper on this topic if you look it up for scan indices. So scan is an indexing technology for vector search that was developed over the last 10 years at Google. And we were able to incorporate that into AlloyDB. And what that allows us to do is really create indices, for on top of the embeddings that really are efficient in terms of performance. The second thing is they take very little memory to build those indices. And the third thing is because it's fully integrated, it's transparent, right, to the end user, to the developer. And we were able to generate faster vector queries, faster index creation, and also typically 3 to 4x lower memory requirements. All of that eventually leads to scalability. So we talked about all of the AlloyDB features, and this is interesting to me because, like I said, I have a background 5 years ago at Oracle. AlloyDB is available in Google Cloud, but like we did before in terms of on-premises deployment, customers still want on-premises deployment. So what we have been able to do is provide AlloyDB Omni as an offering that can be downloaded on your laptop. So it can be running on-prem. It can run in a multi-cloud environment, so it's available on AWS or Azure. It's also really convenient when you want to run in a sovereign, disconnected fashion. And then it is being used by companies on the edge. So if you think about network management companies, for example, they have appliances at the edge of the network that run Postgres, MySQL databases. And these databases currently were hitting issues in terms of performance. Now with all of the features that we have built into AlloyDB, the same capability as AlloyDB in the cloud is available in AlloyDB on-prem. And that's our AlloyDB Omni offering. Obviously, AlloyDB Omni, because it's running on your own hardware, cannot have that infrastructure that I talked about in the initial slides, where you're able to really get good performance out of it. But it's still 2 times faster for OLTP performance than standard Postgres, and 100 times, up to 100 times faster for analytical queries. So there's a lot of capability built into the engine. And finally, I would say that you still are able to do migrations, like in-place migrations from legacy databases into AlloyDB, if that's what you choose to do, without having to move to the cloud. This is my last slide. Just wanted to share with you folks the breadth of the offering that we have across Google Cloud, because there are a variety of workloads. Customers have a variety of environments, and we obviously want to support that heterogeneous environment. We have TiDB as a partner running in Google Cloud. We have other vendors who have their database engines in the cloud. But in addition to that, we recently announced a partnership with Oracle. So Oracle workloads can run in Google Cloud. And then from that point onwards, you can see Cloud SQL, AlloyDB are our relational and HTAP offering. Spanner is for globally distributed setup. It also has a PostgreSQL interface. Bigtable is our NoSQL database. And then we have a document database in Firestore. We also want to make sure that management of this environment is easy. So even around database administration, we have added things like Gemini into our database administration. So it can quickly help you manage governance across a fleet of databases, check for patch levels, see what is compliant. And a lot of the NL to SQL, natural language to SQL capabilities are also built in our tools. So with that, I'll give you a few links here. If you are more interested in learning around AlloyDB, some of the features that I highlighted, what I would say is, the AlloyDB overview page is a good one to start with. And then we have detailed documentation and benchmarking guides and things like that. Resources available. Blogs are really good in terms of the technical details of the product. So take advantage of these, and happy to answer any questions. I'll be around. So happy to answer questions there as well. So thank you very much. Yeah, thank you.